Machine learning is about teaching computers to learn from experience instead of giving them a huge list of rules. To see why this matters, think about how a person recognizes a cat. Nobody memorizes a checklist that says pointy ears must be exactly this shape, whiskers must be exactly this long, and fur must be exactly this color. We just see many cats. We make mistakes at first, we get better, and eventually we recognize cats almost instantly. Some problems are simply too messy for fixed rules, and that is exactly where machine learning comes in. So instead of telling a computer every rule, we give it examples. The computer looks at those examples, finds patterns, and uses those patterns to make guesses about new situations it has never seen before. That process of improving from examples is what we call learning. Now let's zoom out for a moment and connect this to the big picture. Artificial intelligence is the broad idea of making machines act intelligently. Machine learning is a major part of that idea. It is the part where machines improve automatically by using data. And within machine learning, there is a popular approach called deep learning, which uses large networks of simple computing units inspired by the human brain. At the heart of machine learning, there are four ideas that always show up no matter how advanced the system is. First, there is data. Data is just examples. These examples might be pictures, sentences, numbers, sounds, or clicks on a website. If the examples are bad or unfair, the learning will be bad or unfair too. Second, there is a model. A model is the thing that tries to learn patterns from the data. We can think of it as a flexible machine that changes its behavior as it learns. At the beginning, it is usually very bad at its job. Third, there is training. During training, the model makes a guess, checks how wrong it is, and then adjusts itself slightly to reduce that mistake. This happens again and again, sometimes millions of times. Learning is not magic, it is just repeated adjustment. Fourth, there is testing. After training, we check whether the model works on new data it has never seen before. This is important because memorizing answers is not the same as learning patterns. When a model memorizes instead of understanding, we call that overfitting. With those basics in mind, we can now talk about the main ways machines learn. In supervised learning, the computer learns with answers provided. We show it examples along with the correct outputs. For instance, we might show thousands of emails labeled spam or not spam. The model learns the connection between the email text and the label, and later it predicts labels for new emails. In unsupervised learning, there are no answers given. We only give data and ask the model to find structure. For example, it might group similar songs together or find unusual behavior in bank transactions. The goal here is discovery rather than prediction. In reinforcement learning, the machine learns by trial and error. It takes actions, receives rewards or penalties, and slowly learns which actions lead to the best long-term result. This is how machines learn to play games or control robots. Now let's talk about what's happening inside a model, especially in neural networks. A neural network is built from layers. The first layer looks at raw input, like pixels in an image. The next layers combine simple patterns into more complex ones. Early layers might detect edges. Later layers might detect eyes, faces, or objects. Each layer passes information forward, and during training, the network adjusts itself to reduce mistakes. Step by step, the patterns become more useful. This idea of machine learning is not new. The story starts in the 1950s when researchers asked whether machines could think. Early learning machines appeared, but computers were slow and data was scarce. Progress stalled for a while. Then, in the 1980s and 1990s, better algorithms appeared. In the 2000s, the internet produced huge amounts of data, and computers became much faster. In the 2010s, deep learning exploded, especially for images, speech, and language. Suddenly, machines could recognize faces, understand speech, and translate languages far better than before. In recent years, we entered a new phase. Large models trained on massive data sets can now generate text, images, music, and even video. These systems work by predicting what comes next based on patterns learned from data. They don't truly understand like humans do, but they can still be incredibly useful. Modern machine learning systems can also combine different types of information. They can look at images, read text, and listen to audio at the same time. Some systems can even run directly on phones and small devices, which improves speed and privacy. At the same time, it's important to be clear about limitations. Machine learning systems can be biased if the data is biased. They can make confident mistakes. They don't have common sense or emotions. That is why human judgment and responsibility always matter, especially in areas like healthcare, education, and law. Machine learning is already everywhere. It recommends videos, predicts traffic, filters spam, helps doctors spot patterns, and powers voice assistants. And in the future, it will likely personalize education, improve medicine, and automate many tasks, while still relying on humans for creativity, values, and oversight. So the core idea to remember is this. Machine learning is not about making computers think like humans. It's about using data and feedback to help computers improve at tasks. When we understand that idea clearly, everything else fits naturally into place.